Well, now we go ahead. So we will present the photovoltaic project analysis using retscreen software. The case study is a 36 kilowatt installed in south of Spain, grid connected with fixed structure on the rooftop that you can see on the lower left corner. So we will see what's a PV system. Then we will see some differences between the fixed structure and the tracking system. And then we will go across the retscreen module analysis, required inputs, computing, and results. What a PV system consists on: photovoltaic cells connected into modules, modules grouped into panels, panels grouped into arrays. Power conditioning unit, the inverter, transformer usually, and the grid connection. Fixed structure versus tracking system. This is a fixed structure system. There are no moving parts, there is a lower maintenance, and it's more reliable operation. It's easy to install and operate. To give an illustration, average production in south of Spain is 1,500 kilowatt hours per installed kilowatt peak. This is a tracking system photovoltaic. It needs higher maintenance and suffers higher risk of unscheduled outages. It needs more solid foundations and stiff structure. So the additional cost for tracking system is around €1 per installed watt. The average production in south of Spain it's 30% higher than fixed structure, so around 2,000 kilowatt hours per kilowatt peak. So now we will see how to use retscreen module. The required inputs are: what kind of PV panels are we using? So we need the technical characteristics, the nominal power under standard conditions, and of course the cost. Selected inverters, same, what's the efficiency in operation, which are the additional losses, and of course the price. The transformer, what's basically the efficiency in operation and the cost. Miscellaneous like cabling, civil works, grid connection works, support structure, or trackers. Again, what's the cost of each of these items. The land, are we the owner? Are we renting? So this is fixed cost or annual fee. So it would be included in investment or in annual expenditure. Annual expenditure also includes monitoring and security, tracker maintenance, land renting, insurances. So first, the required inputs, which are our PV panels. In this case, we choose these panels, which are around 2 square meters, and provide the power, installed power of 280 watt peak. So with this data, we can determine an efficiency of 14.4 under standard conditions. Standard conditions means 1000 watt per square meter at module temperature of 25 degrees with an air mass factor of 1.5. Another input, inverters. So which inverters we are working with. So in this case, inverters are 3.5 kilowatts and 95% efficiency. Now we need to know where it will be installed. So in this case, here is the location, south of Spain, more particularly there. Why we need that? Well, this is the building, this is the end installation. So we need to know what's the orientation related to the south, and then some angles. Slope of the roof, This angle would be required in order to find the best orientation. And for this additional structure, again, what would be the slope? So now we go into the retscreen computing analysis. So we start feeding, and the basic features are whether our installation is grid connected or an off-grid application. Second important feature is whether we want a first approach or a developed in-depth analysis. There is a good library of site conditions, so we can choose the climate data location. In this case, Tomelloso is the place closest to the installation. Then the model provides the radiation data, the temperature, and the wind data. These are important data. So next step, we choose whether we carry out a developed in-depth analysis or first approach, and then we have the possibility also to select whether it's a fixed structure, one-axis track or two-axis track. Then we have to compute slope and azimuth. So in our case, if given these angles, here we are the formula providing the slope and azimuth. So slope is, let's say, the inclination, and azimuth is the orientation to the south. Well, orientation to the south if we are in the half north of the Earth, and orientation to the north in the half south. Now, the model provides the estimated electricity export to the grid. We have to insert what's the applicable feed-in tariff. So this installation was built before September 2008. So in Spain, the applicable feed-in tariff was 455 euros per megawatt hour, which is quite high given the high radiation conditions. So here we have first possibility to check whether retscreen model analysis is accurate enough. So we have the estimated export to grid by retscreen. Then we have the actual export to the grid. And we have found this deviation, which is basically lower than 10% in all of cases. The month of May was finally very cloudy, so we find at the end of the year a deviation of -2%, so it was not a very sunny year, especially in the month of May. The rest of months we can see how in the average, retscreen provides a good approach. So now we are going to compute the panels. So the input data are which kind of panel are we using, so what's the power capacity to be installed, so in our case 36 kilowatts. We introduce also the efficiency of the panels that we have calculated before. And then the model provides how many units I need, what's the solar collector area. Here we have some figures about the cost. This is the cost breakdown declared by the project developer. So we can see how at that time in Spain the prices were quite inflated. 4.5 euros per watt for PV panels. Today we would be around 3 or even lower than this. The total installation was around 6.1 euros per watt for fixed structure, which is, let's say, quite high for today's figures. Today we would be around 5 or even lower. So this is the cost breakdown, and we can see how PV panels are the biggest expenditure chapter. So retscreen provides financial analysis. We have to provide some inputs as inflation rate, project life. So feed-in tariffs in Spain go up to year 25, so we can do a business plan over 25 years. The debt ratio, in general, these projects were financed up to 80%, so equity 20%. Debt interest rate applicable typically 6% at that time, and debt term 10 years. The cost, as we have seen, reached 219,000 euros. So the model provides the outputs. So internal rate of rentability over equity reaching 20%. The internal rate of return on assets 7.4%. So it means around 10 years for payback. This is the cumulative cash flow. So we see how in the year 10 we have completely provided the debt, and then we have net positive cash flow. There is also a possibility for CO2 emissions analysis. So basically we have to provide what's the reference power generation technology, and related to this the model estimates the net annual emission reduction. In this figure we have a 2-axis track installation. This installation is 33.6 kilowatts. We haven't developed the analysis we use in retscreen. It's basically the same as before. We only have to choose 2-axis track, and then we obtain the new figures on production, and so that's all. So thank you very much. This is, let's say, the introductory analysis. Now I suggest going across the real program of retscreen. So I'm going to switch to my computer screen. 1 second, please. Okay, so now here we are, retscreen model analysis. So how do we proceed? This is project name, so we enter our project name, project location, prepare for, prepare by, and then here we start choosing technologies. What's the type of project? Well, we have several possibilities: power, heating, cooling, combined heat and power. So in this case, this is power. Which kind of power? We have several possibilities: fuel cell, gas turbine, hydro turbine. In our case, it's photovoltaics. What's the grid type? We have possibility for isolated grids, for central grid, off-grid. So type of analysis, basically method 1, first approach, method 2, more in-depth. Heating value reference, well, for photovoltaics it's not applicable. We can choose the language, the currency, in this case we choose euro, and metric units. Site reference conditions, this is powerful tool. So if we open that, we can see this window with radiation data. So we can choose the country and the closest location. So we accept. Then here we can see the radiation data for January, February, March, and so on. This is a basic input for our model. Then we go to the next step. Then again, we choose the kind of method. Here we go across fixed structure, one axis track, two axis track. So in the second case, we would choose two axis track. For our main case, this is a fixed structure. We provide the angles for slope and azimuth, so basically inclination and orientation to the south or to the north. Then we show here data of radiation, split it by months, our feed-in tariff, and then the exported electricity. We provide the kind of technology, whether it's monocrystalline, polycrystalline, so on. The installed power, 36 kilowatts. Efficiency, 14.4. Miscellaneous losses, around 1%. Then inverter efficiency, 95%, and the capacity. So this is the emission analysis. So here we can choose what's our benchmark, whether we are producing with coal, with natural gas, what's our benchmark. For instance, if we choose coal, there is a higher emission level per megawatt hour. So in this case, the net annual greenhouse gas emission reduction is of 50 tons CO2. And then financial analysis, where we input all this data, okay, inflation, project life, debt ratio, so on, our investment, and then here we find the cash flow graph and the main figures of internal rate of return. So here we are. So we come back now to the presentation. So that's all. Now we open the session for questions and answers. First point, the project developer in FreeSol unfortunately cannot be with us. However, you can submit the questions. For very technical questions will be answered afterwards by our specialist and installer in FreeSol. Thank you very much. So now you're invited to submit your questions. Okay, so we are going to make bigger our windows. Moment, please. Okay, great. Okay, so now we are going to address your questions. Some questions are coming. So there is a first question. Let's submit it. So, first question from Jeffrey Browson. Thank you. How did you arrive at the equations for geometry, tilt and azimuth? I missed the equations. Well, thank you for the question. Well, these equations were not explained. Um, this is, let's say, basic trigonometrics. However, we will publish the reasoning behind that. So it will be published in our website for more precisions. Thank you. So let's go across next questions. Question from Brian. Can retscreen be used to optimize a design for a given area and also be used in the energy if the energy policy is based on imports and exports, not feed-in tariffs? Well, indeed, I think there are some flexibilities. Of course, if you have a design and you want to optimize, you have only to test different configurations, whether you have a orientation or the inclination, or choosing one type of panel or other type of panel. If you're surface constrained, so you can play with a different kind of inverters, panels, and so on. About whether it works only with feed-in tariff or not, of course you can again introduce your personal data, your particular data. So do not hesitate to explore that. There are several possibilities. So yes, in principle, this is possible. So now a question from Costas. So the question is whether the radiation data from retscreen are compatible with PVGs. Well, I'm not the personal expert on retscreen, but retscreen is working with NASA data, not so much with PVGs. So um, uh, I'm not sure this is 100% compatible. This is certainly an alternative source of data. As far as I know from former experiences, the differences are not so big. So you can use in a quite reliable way, as we have seen before. There is no much difference, around 2% related to real life. So this is quite good figure. However, in any case, I announced you one upcoming webinar in the month of February and in the month of March about software to determine solar radiation with a very high precision. This is a new system, and then you will have the opportunity to discover that. So you will be announced in very soon. So next question, how much does the software cost? Well, actually, this is free of charge, so you can find the downloadable version on the address indicated there, retscreen.net, and then this is completely free of charge. So next question, you mentioned a 2% accuracy for the red screen results. Is this consistent across multiple projects? Well, unfortunately, we didn't check across many projects. We just chose this one, and then we found out that minus 2% is, I'm afraid, related to the fact that in the month of May it was very rainy and cloudy, and then this computed for a lower annual average production. So in general terms, seems to be quite satisfactory, but we don't have checked for projects enough. Would be interesting to submit this question if you want more data from the field directly to retscreen representatives through the website. Next question. Can you take into account shadowing effects? Well, as far as I see, there's no possibility to take into account these effects. In the advanced model, there is maybe this possibility. I can't ensure you. You will have a more precise answer in the publication we will do of this webinar, recorded, and we will publish the questions, and then we will check with red screen representatives whether this shadowing possibility exists or not. Next question, was any other simulation software used, and if so, how did it compare with real life on red screen? Well, we didn't do that exercise. We only used red screen to check whether we find comparable results to real life or not. We checked how it's quite close, but we didn't carry out a complete benchmark on other available software. So again, back on angle calculation, so it will be published. Actually, we didn't explain, but there is a trigonometrical demonstration, so you will get it. Next question: how to proceed for a new project for a building to estimate the right area? Well, actually, if you have a project, you should know what's your roof area, what's the slope of this roof. So based on that, and what's the orientation to the south. So based on that, you can compute again this data. So you can both do on ex post basis or ex ante on project basis. The next question related to where can you find the software, a tutorial again on this website, retscreen.net. It's available, and there is also a tutorial. So is the manufacturer data up to date? Is kept up to date? Yeah, indeed. Manufacturer data are kept up to date. However, on real project basis, it's better to use your directly your data sheet. So as we did in our presentation, we took our manufacturer's technical specification, and then we checked very exactly what's the surface, what's the efficiency, what's the nominal power. For the first approach, you can certainly use this database. However, important factor is the price, and then for the price you need to consult your manufacturer, your provider. Next question, what are the difference in power output between fixed and tracking systems? Well, basically, for locations where you have enough radiation data, again, this is a trigonometrical calculation, then it's roughly 30% higher when you use a tracking system. Provided, again, I repeat, you have enough direct radiation data. If you don't have direct radiation, in this case, it's difficult to um, to justify a tracking system. So if your radiation is basically diffuse, then go for a fixed system. If you have a lot of direct radiation, so it means no clouds, then tracking system can be justified. Additional investment is €1 per watt, and then additional production is 30% higher. Well, next question is relative to, let's say, software difficulties. So I recommend you to uninstall, then reinstall again, and should be working properly. For further questions, do not hesitate to go to retscreen website and submitting your doubts. So next question, what should be the tilt angle for PV? These tilts vary according to the area, I mean the longitude and altitude degree. I'm not sure to have understood very properly the question, however, we will try to answer. Well, you have several possibilities. According to your location, you have an optimum tilt angle. So optimal azimuth is definitely oriented to south or to north, depending on whether you live in the north hemisphere or south hemisphere. Second, basically it's latitude which provides you the optimal tilt angle. Then according to this, you can be free in choosing your angles. Then in this case you will go for optimal angles. Otherwise, if you are constrained, this software can estimate what would be the production in your particular case. Another, let's say, IT question, whether there are similar programs that runs with Mac or OS 10. Well, this is quite technical question, not treated here. So for these kind of questions, please refer to retscreen. Thank you. So next question relate to how does price indicators exist on retscreen database. I'm not sure you have price indicators for all your components. So for price, it's better to consult your provider or consult catalogs on websites or ask for a quick quotation. In PV world, prices evolve very quickly, so the important recommendation is to obtain an updated price by consulting directly with manufacturers or local dealers. So next question about retscreen users discussion group. I have no answer now. I will try to have an answer when publishing this webinar on our website. Do not hesitate again to go to retscreen website. So next question, have you considered the effects of performance degradation? If so, what are the most important equipment in performance degradation processes? Yeah, so this is a very interesting question. Degradation has not been taken into account in this model. There is probably a possibility to take this into account. For sure, you can consider an average degradation. The main factor for degradation is PV panel. PV panel efficiency, well, output, let's say the PV panel output for the same radiation data is losing about 1% per year. So in this kind of projects, we are talking about 20 years, 25 years. So that means that in the year 20, you will have an efficiency 20% lower than beginning of the project. So indeed, should be taken into account. In this case study, we didn't take into account explicitly, but you can afford for an average performance reduction for the whole project life. So next question, can retscreen introduce and include energy loss in order to run a tracking system? Well, I think that in this case you should directly consider a loss of performance of your system or just an additional loss to feed the tracking system. Well, in general, tracking system will not consume lots of energy for sure. However, there's no explicit option for this, so you should probably include or make a provision for it by your own. So there is another question about what's the cause in performance drop? Well, there are several sources of performance drop. Well, first of all, if you mean in the time, basically PV panels lose performance with the time. If you mean the performance of the global installation, then basically you have cabling have some losses. Transformers, in this very case we didn't have any transformer, but in general you will have. Also inverters, so at the global efficiency you have all these elements in line and then all with their efficiencies. Well, one similar question, does the problem cater for reduction in efficiency due to lack of cleaning of panels? Well, I'm afraid it's not so advanced. However, again, this is an assumption you can include by decreasing the efficiency of your panels or by introducing additional losses. Another question about degradation. Is the degradation the same for CPV? Well, this is very advanced question, so I suggest you to go to websites and be in touch with ISFOC experts, which are carrying out a good survey on the field for several technologies of concentration photovoltaics. So I let you know the website. 1 second, then you can be in touch with them. They will provide this kind of figures. Yes. So next question. What's the point I should take it from the retscreen program, and that can help me in take the decision? Well, retscreen program is useful for project developer. So this is, well, technical economical analysis. It means that you can make your decision based on whether it provides a good internal rate of return. Basic inputs are your investment, so you need to know how much your global system will cost. We have provided here some guidelines on the basic equipment. You need to know what price would be sold the electricity, or what's the alternative electricity generation cost. And then in this case you will have rapidly the answer whether it has value for you or not. So this tool is interesting for, let's say, very upstream phase of the project, when you have to decide whether you have a good margin in internal rate of return or not. So next question is about the cost per watt in dollars using photovoltaic system nowadays. Well, this is evolving very quickly. A figure which is used in Europe is for fixed system should be around 4 to 5 euros per watt. Probably closer to 4 than 5. So, well, in dollars you should do the conversion. It's the rate exchange is changing every day, so it couldn't provide a good answer right now. But well, in euros it's around, for fixed charge structure, around 4 euros. This is evolving very quickly. It will be not surprising that we find lower and lower investment cost in the coming months and years. So another interesting question: how does the ambient temperature affect on PV performance? Indeed, the higher temperature is, the lower performance. So this model takes that into account with a standard temperature and standard temperature loss of performance. However, you can introduce on hand your particular features. So indeed, it should be taken into account. In hot climates, you have a performance degradation. So, next question by Mr. Carl Pedersen. So PV generally have a long payback period. How long would you estimate a panel's lifespan would be before a replacement would be warranted? Well, the warranty currently used in these solar panels in Spain up to the last year, or well, general worldwide up to the recently, is 20 years. 20 years warranty with a maximum loss of performance of 20%, which is roughly, as I told before, 1% per year. So yeah, indeed, payback period should be definitely lower than 20 years. Your business plan, in this case, we planned over 25 years because feed-in tariff in Spain go for 25 years. However, from a warranty point of view of panels, you should stop at 20 years. So indeed, let's say we are around 20 years for a business plan, and payback period for sure should be lower than this. It all depends on what's your risk willingness and what's the internal rate of return that you are required to produce. So next question about installation of panels. So a local installer places panels vertically on the wall of a house. They run cooler and do not accumulate snow. I'm assuming this works well with a low winter azimuth. But will the indirect angle in summer significantly reduce energy input? Well, I think that retscreen can be useful in this case as there's discrimination on generation by months. So by changing your angle and your orientation, you can consider the production in winter, in summer, and then optimizing according to your local conditions. So basically, you should take into account whether you have a difference in winter related to summer in terms of prices, in terms of generation you are looking for. If you are connected to grid and on a logic of feed-in tariff with, let's say, annual income target, in this case you should only consider the maximum annual generation. But if you are on off-grid application and then you want to cover your needs, then you should of course choose your angles and your orientation according to the highest needs, whether it's in summer, whether it's in winter, and then optimize according to your particular needs. So I think that retscreen allows for a possibility of playing with angles and then checking month by month your generation. So we find now some questions relative to the efficiency decrease over the time. So for the Spanish project, does it mean that 20 years later the efficiency becomes 11.6? Yes, indeed. This is the point. This is definitely the point. So similar question, efficiency of PV by time, how it decreases, a percentage it can go. So we have already indicated that. So account by 1% per year. So completing the question before and the explanations, Neil Burgers indicates that should make sense the question about orientation and tilt angle and generation over the different months. He doesn't install tracking, but the bracket does allow for a change in the angle for the summer, where the panels block sun from the window, shading the window. Very smart. I will check retscreen. Well, indeed, this is definitely a very interesting solution. Fixed structure with possibility of changing the tilt angle. Yeah, sure. But in this case, if you want to estimate generation, then you should split the estimates from retscreen with different angles applicable for different months. So in this case, you should build by your own your generation curve along the year. But indeed, this is another possibility. Explicitly, retscreen doesn't allow for that, but you can build your own model by taking the results from retscreen on month per month basis for a given angle. Similar question about periodic manual adjustment of the azimuth, well, of the, let's say, the slope orientation to the south or to the north is given, and the optimal is definitely oriented to the south or north. So about the tilt angle or let's say the slope, yes, indeed, again, as we have explained right now, smart solution is fixed structure with 2, 3, 4 positions optimized for winter, spring, and summer positions. So next question asks to put the financial analysis view on the screen where we are preparing questions. Okay, so I'm doing that. So this is the slide. Okay. So I think that we are approaching to the end of this webinar. We will publish this the recording of this webinar, and the presentation will be available. Keep in mind that retscreen software is free of charge and downloadable from the website of retscreen. We will be happy to welcome you again on these webinars. We have expected other webinars on concentration photovoltaics for this year. We have 2 webinars about estimation of solar resource by new technologies. So you will be welcome. Also on the use of retscreen in 2 weeks. In 2 more weeks, we'll have a case study on wind, small wind. So I think should be of your interest. Well, now we will address afterward the rest of the questions. They will be answered on our website, so you will find the publication in the coming days. Thank you very much, everybody, and see you soon on Leonardo Energy and these Friday webinars. Thank you.